We're on the air. Okay. So section 5.4, we're going to continue it. We're going to integrate exponential function. By the way, for the record on this video, that is not an recorded laughter. This is a live audience laughter. All right. So with these integrals here. Now this is what we did yesterday. This is the reverse of what we did yesterday. But integrating e to the x is still e to the x, right? When you derive e to the x, what do you get? E to the x. Okay. The e to the u is just used for either chain rule substitution when deriving or u substitution while integrating. The one thing though, remember e to the x, again, it's the same when you integrate, but you have to remember your plus c when you integrate. You don't have to have the plus c when you derive. Okay? So I've just got two examples we'll take a look at. Are we good on moving this up? We got that written down? Okay. So a couple examples quick here. Just integrating exponential functions. I believe that's so we can see it. For example 1, we're going to integrate e to the 3x plus 1. And that'd be dx. Okay? So again, this one we'll have to use u substitution because it's not a single variable in the exponent. And I think it's pretty quick and easy to see what's our u. What are we going to set equal to u? Yep, u will equal 3x plus 1. When we use the u substitution, we have to derive u. So we get du equal to 3 dx. And remember, we want to get what by itself here? Yep, dx. We get dx equal to du over 3. Okay, and now we can substitute the u and this, the du over 3 in for the 3x plus 1 and the dx. So we'll go ahead and do that next. So this would look like, oops, I'm moving that a lot. This would be the integral of e to the u times du over 3. Again, this process should look familiar to what we did in chapter 4 with u substitution. It's a good review of that as well. What number can I move out in front of my integral here? Yeah, 1/3. This would be like 1 over 3. Notice with this one, you don't end up having any cancellation. On some you will, some you won't. But we could write this, and this step's up to you if you want to do it or not. 1/3 integral of e to the u du. Of course, when we integrate e to the u, it's going to look exactly the same. It would be 1/3 e to the u plus c. Can't forget the plus c. And then we'll put this back in terms of x to finish it up. So our final answer, we could just write e to the 3x plus 1 over 3 plus c. And you could keep this as 1/3 if you wanted to. It's up to you if you want to have 1/3 e to the 3x plus 1 or just put it over 3. Either option is okay. So that would be our final answer on that one. Questions on example 1 after doing that? Anything we can take a look at there? Okay, we move it up here. We'll do example 2. And again, I'll send this to you guys on Google so you can slow it down or go back and look at something if you'd like. For this one, we've got the integral of 5x e to the negative x squared dx. And again, you get a pretty good idea, pretty good feel, start to identify what we want to have equal to u. What are we going to set u equal to this time for our substitution? You have negative x squared. Again, with these e exponential functions, we have to have e to a single variable for its exponent. So right, we're going to say u equals negative x squared. So let's do this off to the side. U equals negative x squared. Oops, too far off to the side. There we go. And then derive that, du would equal negative 2x dx. And then we want to get dx by itself. And so it would be du over negative 2x. Okay? And some of you guys might be realizing that shortcut idea we did in section 4.5 can apply to these as well. So if you're seeing that, and you can do this a little quicker, that's perfectly fine. If you like having the process to work through, that's fine too. It's whatever you guys would prefer with that. Let's go ahead and do our substitution. So now we'll have the integral of 5x e to the u, and then replace dx with du over negative 2x. And we'll do a couple steps in one here. We can move a fraction out in front again. What fraction can we move out in front of our integral? Yeah, 5 over negative 2. So we just make that negative 5 halves. And then, what's that? Right, the x's, yeah, you get the x on top here. It's going to cancel out the x on the bottom. And so we already moved the 5 and negative 2 out in front as a fraction. So now we're just integrating e to the u du. So if we do that, again, e to the u is the integral of e to the u will still be e to the u. We just got to remember our plus c. So we'd have negative 5 halves e to the u plus c. And then our final answer would be then to put this u back in terms of x. So we'd have negative 5 halves e to the negative x squared power plus c. And that'd be our final answer. Again, any questions we can go back and take a look at with example 1 or example 2. Yeah, Lauren?
With the, can you make it 5e to the negative x squared over 2?
Oh yeah, yep, you could write, yeah, just like we did on the previous where we just put it over 3.
Okay.
Yeah, you could definitely do that. Yep, that'd be fine. Yeah, and again, the book, like we've kind of seen in this chapter a few times, or quite a few times, the book might have a slightly different representation of the answer, and there's still equivalent representations, and that's fine. Okay. Any other questions on either of those two examples?